Hi guys, this is MTech Internationals, and today we are presenting to you about one's complement. So first of all, I'll start by defining what one's complement is. So one's complement of a binary number is a value obtained by inverting all the bits in the binary representation of a number. So that is the definition of one's complement. But it also have some uses, and the main use of one's complement is to represent a signed binary number, and apart from that, it is used to perform various arithmetic operations such as adding and subtraction. So let's start. In one's complement, there are few basics that we consider, and these are: the leftmost bit is used for the sign of a number, and if the number is positive, it is indicated by a 0, and if the number is negative, it is indicated by a 1. So always remember that the leftmost bit is used for the sign. How to represent integers in one's complement. A positive integer is represented in the same way as it is represented in signed magnitude, from using the fixed number of the bits indicated. So we are going to find out about that as we go into the video, deep into the video. So a negative number is represented by flipping the bits of the positive version of the integer. That is changing 1 bit to 0 and 0 to 1. For example, 13/10 is represented in one's complement using 8-bit system. You should remember that in one's complement, we use the standard of 8 bits. So 13 is represented by 0, 0, 0, 0, 1, 1, 0, 1. And 13 in negative is represented by flipping the zeros into ones, and that is 1, 1, 1, 1, 0, 0, 1, and 0. So that is how we do it. So as you can notice on the screen, 13 positive, the leftmost bit is a 0, which means it is a positive. And on the negative side, 1 is on the leftmost bit, which means it is a negative. So you should not forget about all those basics. Steps to follow when doing one's complement. There are few steps that we follow before answering the one's complement. And the first step is that determine whether the number is positive or negative. So you determine the given number if it is positive or negative. And step 2, if the number is positive, then write the number in expanded notation and simplify. So if the number is positive, there are no problems. You just have to write the numbers into expanded notation, which means turning them into binary system. If it is 13, for instance, you can turn it into binary system by using that table of base, number, and remainder. So after you turn the number into binary system, you should simplify if it is a positive. Step 3. If the number is a negative, then find the complement of the number. What do I mean about that? This means that you should flip every 0 to 1. So that only happens if you have turned a number into binary system. And if you turn the positive number into binary system, then if you want to take it to negative, flip the zeros to ones and ones to 0. Then the numbers become a negative. And after that, you simplify. So Let's apply those rules by doing this simple exercise. So we are going to add 5 base 10 plus 38 base 10, negative 47 base 10 plus negative 20 base 10. So you should remember all the basics in this video to represent a 0 into a 1. I mean flipping the 0 into 1s in order to change a number from positive to negative. So for instance, on 5 base 10, if you turn 5 into expanded notation, which means binary, you have to flip the zeros into 1 and ones into 0 in order to make it negative. I'm just giving an example. So make sure you do the exercise and send the feedback after the video.